Good morning, everyone. So, I welcome you all for this career guidance. I welcome you all. Like, this is the lazy Sunday, and still we are here to discuss about the career opportunities and the career guidance. So, it means so much because, like, some of the participants or the some of the candidates might be having fun today, but we are here because we want to learn something new and we are very much serious about our career. So today we are not just going to talk about the job or the how to proceed further in my career or how to set a life goal, but we are going to talk about what exactly this industry demand or what exactly this industry needed from the fresh graduates. So when I say a fresh graduates, it means you might be an engineer, you might be a diploma holder, or you might have just cleared the HSC exams. So there is something for everyone in this industry. But the problem is we are not sure, or I might say that we don't know that where to search it and how to get it. So those who joined this live session, I'll request them to just put in a chat box that your education, like whether you are done the engineering or you done the diploma. So you can just put into the chat box. So I'll get a correct idea that what kind of audience today we have. So you can just write in a chat box that engineering is completed or diploma is completed. Those who just joined, you can write in a chat box your completion of degree, like either I did the engineering or I did the diploma. Okay, so we have a diploma mechanical engineering here. Okay, diploma and btech both are completed. Then we have b electrical. Okay, some of completed in 2023. Okay, so we have some participants who completed their diploma and some completed their degree. Okay, we have mechanical students also, right. So once my graduation is completed, once my engineering is completed, as a normal mechanical engineer, what do we always look for? Or the placement department of your institute will always get the companies who are dealing with either designing or the production engineering, I'll say, or the quality control. So such kind of jobs we get through the colleges. I'm not blaming college for that because they are doing their job very well. The syllabus is designed under the Mumbai University, and we do have the revisions on the syllabus, but still it is not that drastically changing because the current industry need which is needed is not fulfilled by the institute itself. Although they are doing tremendous, they are putting tremendous effort on the students. They do different activities to gain that missing link or to gain that missing knowledge. They bring it to the institute under the institute interaction program or under the guest lectures or under the seminars. So such kind of activities in the institute do, but still there is this gap between the industry and the institute. Institutes provide you all the theoretical knowledge, all the concepts, all the principles are getting clear. But still, when we start working into the industry need to train us. They train us according to their working culture, according to their working philosophy, and then we start doing some. important task for the industry by which they get the profits. But initial few months are like the industry is training you as well as they are giving you the salary. So it is a kind of loss to the industry. So to overcome such situation, to overcome such problems, what we do, we are the Suvidya Institute of Technology. So what we do, we provide this skill based training programs. Now you might get confused, like I did this engineering, I did my diploma, I completed this graduation, then what is the need of this training program? So the need of this training program is it will fulfill that gap which is present in between the institutional knowledge and the practical knowledge which is needed into the industry. So I have one question to all of you. Apart from this quality control and inspection, apart from designing of the object on AutoCAD, and apart from your site engineering, ये सब छोड़ के और आपको कौन से जॉब प्रोफाइल्स अवेलेबल है मार्केट में, दोज आर दोज प्रोफाइल यू आर वेल अवेयर अबाउट इट. तो ये सब छोड़ के और मार्केट में कौन से टाइप के जॉब प्रोफाइल है, यू कैन पुट इनटू द चैट बॉक्स. PLC and SCADA, okay, very good. Document controller, okay. We are having a 5 years of experience, very good. Project engineer, right? Boiler engineer, CNC operator, very good. Piping engineer, oh, Sonu Gaur, piping engineer, utility, very good. So those who are answering like a boiler engineer, project engineer, utility are the fresh graduates. Because during the time of engineering, the engineer don't have such kind of knowledge that there is something called boiler engineering or there is something called utility management or the piping design engineer. But if you are having such knowledge at this early stage, then you did a great work. So when we say that apart from this, there is something this industry can offer, and there is something where we can actually work. So such kind of industries are like today we are discussing about is the oil and gas industry, the EPC sector. So we are going to talk about the oil and gas industry and the EPC sector, and how these companies, or I'll say how these sectors have such a huge demand of engineers and the diploma holders. So we'll step by step proceed further and we'll deep dive into this topic so that at the end of this seminar, we will be well aware about what kind of streams are available, what kind of jobs are there in the market, and where I can fit in perfectly. Or I'll rather say where I'll give my knowledge or I'll share my knowledge with the industry so that the industry will be getting the benefits, and as well as in return I'll also get some benefits. Okay, because as a normal human being tendency, what generally happen, like if I'm putting so much of amount, so much of money into this engineering, then at the end of my degree or at the by the completion of my engineering, there should be some ROI, that is return on investment. So within how many months I can recollect my fees. Okay, so such kind of things happen. So here we'll discuss about this in depth detail, and I'll make sure you will understand everything perfectly clean, crystal clear. Okay, so let's start with it. So as you can see, here it is the career guidance seminar for the fresh graduates, and this seminar is organized by the Suvidya Institute of Technology. We are the one and only institute which provide the ECITB certification, that is from the United Kingdom, as well as we are under the NSDC, that is the National Skill Development Corporation. So we do provide the certification under the logos of NSDC and the ECITB. So this certification will help you that to proceed further in your career, and which will make sure that you will gain a practical knowledge very well. Okay, and one more thing here is, while the commenting, or like we are typing here in a chat box, so you do have to subscribe to the channel. So like we are always doing such kind of activity which create the awareness about the industry, so which will further help you in your career and which will enhance your knowledge. So do subscribe to the channel, and then it will be easy to comment under the chat box. Okay, thank you so much, Suraj. Okay, so this oil and gas industry basically divided in three different parts. One we call the upstream, then second is the midstream, and then we have the downstream. So why this name comes, like why we are calling it upstream, midstream, and downstream? So basically, our day-to-day life is moving around this oil and gas industry. The early morning you wake up, you go into the kitchen and you start preparing a meal or you start preparing a food. So from that end, from that point, you are related to the oil and gas industry. Once you are collecting your tiffin and you went out of your home for the office, you are going through the bus or the train, or any of the mode. At the same time also you are connected with this industry. When you reach to the office, you start doing work. The data is generated, it is stored somewhere, it is transported from one end to another. If you are in a manufacturing industry, the products are being transported from one end to another. So each and every stage of your life, you are connected with this oil and gas industry. Now the question may arise कि ऐसा कैसा होता है सर, ऐसे कैसे possible है? Okay, so our, like the current hot situation we have here in India, the E20 and the पेट्रोल का इफिशिएंसी कम हो रहा है, मेरा गाड़ी मेरी खराब हो रही है, उसमें पानी आ रहा है, एवरीथिंग. सो ये E20 and this petrol, so this petrol ये आया कहाँ से? So this petrol is the last product which we are getting from the crude oil. Okay, so now the question will arise, like how I can get this crude oil? So this oil and gas industry revolve around the natural gas and the crude oil. So the time I figure out that at this particular location I can get the crude oil. So from this point till the petrol in your tank of your vehicle. So all these dots if I connect, it is making the huge sector which is called oil and gas sector. So I hope you are with me, guys, that you are understood this very well. So have you heard about this oil and gas sector previously? I'm waiting for you in a chat box. Okay, they just know this very well. Sarvatnya, Akshay. Okay, very good, very good. So this oil and gas sector, the basic thing which we are doing is we are drilling and taking out the crude oil from it. This particular industry is also known as the petroleum industry. So this petroleum word is come from the Latin word. So where we have where it is known as the Petra, as you can see on your screen, the Petra is nothing but the rock, and the oleum is nothing but the oil. So if I combine it perfectly, I'll get the petroleum word. Okay, and which also includes the crude oil, the natural gas, and all the refined products that we are getting out of it. Okay, so in our nature, we have the crude oil, we have the natural gas, but it is not available everywhere. It is limited to some different locations. Like we can say we have this available offshorely, and we have this available onshore. So there is a different technique to get it out from the earth crust. So if we are doing on a offshore, so there will be a something different system. If I'm doing it on a onshore, then there we have different system. So as you can see, this industry itself is further divided in two parts. One is the offshore engineering we can call it, and one is the onshore engineering that we can call it. But on every stage of engineering, on every what I can say step of this process, we needs the engineer, and those engineers will be your mechanical engineer, your electrical engineer, your instrumentation engineer, your civil engineers. So this on this every stages we need this engineers so that they can show their work, they can do it properly, and the things will get done perfectly. Okay. So as I said earlier, this oil and gas sector is further divided in three parts. One is the upstream industry, the second is the midstream, and the last one is the downstream. So when I say upstream, as the name suggests, something which is coming out of the thing, something which is going upward. So when I say upstream, so it is nothing but the exploration and the production. Exploration as in we need to find out the place, we need to figure it out how I can take it out this crude oil from the earth. So there is the huge demand for the engineers, and there are certain companies which do provide or which are only limited for the upstream. So there are these companies that we'll talk about later on, and we have I also mention it into the upcoming slides. So when I say the upstream industry, what I do, I'll do the exploration, I'll do the production of this crude oil. Then the next stage come as a midstream. Now I explore it, I take it out from the earth, but now what I do? Should I directly supply it to the petrol pump? No, that is not possible because I need to do something in between. So what I'll do, when I take it out from the earth, I'll store it somewhere. So this storage and the transportation is known as the midstream industry. So under the upstream, I'm taking it out, I'm exploring and doing the production of this crude oil or the natural gas, I'll say. Then this thing I'll store into the storage tank. The storage farm is also there. So we do the storage there, and then we'll transport it to the further processing. Now, while we do the further processing, so this further processing is nothing but the refining. So I'll do the refining of this crude oil. We have the distillation column. We boil this crude oil and then distill it at the different temperatures, different pressure range, and according to that, I'll get the byproducts. So it will be your petrol, diesel. You will get naphtha. You will get so such kind of products will get at the end of or during the distillation process. So as you can see, to do the upstream operations, we need different kind of machinery. To do the midstream operation, we need different kind of structures. And to do the downstream operations, we further need different kind of machinery, different structures, different piping, everything. So as I said earlier, once my graduation is completed, once my diploma is completed, I need to learn something which will include the knowledge of this upstream, the knowledge of this midstream, and the knowledge of this downstream industry. So when I am fully aware that this is the work I need to do under the upstream, this kind of documentation, this kind of processes I need to follow under the midstream, and such kind of drawings and such kind of calculations I need to do under the downstream, then and only then I'll be capable of selecting the each field perfectly. Are you getting it, guys? So am I clear with you guys? Those who just pass out and these things are new to you, but I hope this explanation bring you the light and bring you that clarity that how this industry work. Okay. Okay, so we'll move further. Okay, so as we discussed earlier that during the upstream what we do, during the midstream what we do, and during the downstream what we do. So as you can see on your screen, there are the different industries for different kind of operations. Like when I say upstream, so what do? We extract the crude oil or we extract these hydrocarbons from the earth. So to do the extraction for the natural gas extraction or the natural gas production, the technology provider or the equipments which we use are different. The same way for the oil pumping or taking out the oil from this earth crust, there are the different technologies. Now, once this oil is taken out, this crude oil is taken out from the earth, what we need to do, as I said earlier, we need to put it somewhere. So we need to design the storage terminal. Now, when we do the piping engineering, or it is such kind of training program where we give you the knowledge about the upstream, midstream, and downstream. So in the midstream, there is this storage terminal and the storage, or we can say the tank farm. So there is the calculation to design such kind of tank farms. So how much should be the height of the tank farm? How much volume it should occupy? How much space I need to provide on each side of that tank so that if any spillage will happen, then how to control and how to mitigate such problems. So each and every concept and each and every calculation is very much important while doing the engineering. So when we say engineering or when I say the piping design engineer, so it means you are going for the in-depth calculation. Your mind should be open for all kind of things will happen or all kind of problem that system may face in future, because you are designing today, it will get fabricated or constructed within a year, and then actual operation will start after that. So the total life of that equipment should be almost 25 years. So you need to think in a such way that after the 25 years or during the tenure of this 25 years, what are the different things will happen with it, and I need to mitigate it or I need to do the preventive things for it priorly. So this is how the engineering is. It's very crucial and it's very important. And if you love this engineering, then it will be very fascinating field for you. So as I said, the midstream industry is nothing but you are taking the crude oil and now you are storing it and you are moving it to the further processing. Now when we comes to the downstream, so under the downstream what we are doing, we are processing it, we are refining it, and we are getting out the finished products. So like there are the different products under the distillation column at the different temperature, different pressure range. So when I figure out that at this particular temperature range I am getting the petrol out of it. Now once I am getting the petrol, what should I do with it? Further, I need to store it somewhere. So initially I stored the crude oil, and then pass it over the refineries. Then from the refineries, I am getting the product that I pass it towards the another storage. So you can see the midstream industry is on the two sides of your downstream. Initial storage transportation, processing, further storage and transportation till the end user. Now the end user will be the consumer, right? The petrol which we use, the diesel which we use, further things which are needed under the process industry. For the cosmetics we needed, right? For the energy sector it is needed, for the semiconductor industry it is needed. So such kind of things are generated under this oil and gas sector. Okay, I hope these things are clear with you. Okay, so we are on the same page, right? So now we'll move further. So we have to further explain about the export
Oil and
opportunity.
gas, also known as hydrocarbons, provide much of the energy needed to power homes, cities, and industries around the world. Offshore wells are drilled by companies to discover oil and gas, or to develop and produce already discovered reservoirs to process into usable energy. Woodside is Australia's largest independent oil and gas company, known for our world-class capabilities as an explorer, producer, and supplier of energy. Over our 60-year history, we have safely drilled over 600 wells in offshore environments, both in Australia and internationally. Before drilling, Woodside undertakes detailed well design and logistical planning, applying good industry practice to ensure our wells are drilled safely and potential impacts to the environment and other marine activities are minimised. We consult with stakeholders, including local communities and fishers, to explain our planned activities and understand how potential impacts can be avoided or minimised. These potential impacts and other possible hazards associated with the drilling activity are monitored and managed throughout drilling operations. Woodside also prepares environment plans that detail how drilling will be undertaken and obtain approval from relevant regulatory authorities before drilling commences. Wells can be drilled by either a drill ship or a drill rig, known as mobile offshore drilling units or MODUs, depending on water depths and other factors. To ensure the safety of other marine users, vessels not involved in drilling should stay at least 500 metres away from the drilling location while in operation. This is called a safety exclusion zone. Once the well is complete and drilling infrastructure is removed, marine users are generally free to resume normal activities. While technical differences exist, the process for drilling all offshore wells is similar and take place in several stages. Before any drilling, a remote operated vehicle or ROV is sent to assess the condition of the seabed. A hole is then drilled into the ocean floor using a large diameter drill bit, and steel pipe called a conductor is installed, providing the well's initial structural support. A smaller drill bit is then lowered through the conductor to drill the next section, which is called the top hole. Once it reaches a predetermined depth, more steel pipe called casing is installed, supporting the newly drilled hole. Cement is pumped through the casing, moving between the casing and the drilled hole, securing it in the ground. The cement is allowed to set before drilling continues. Before drilling deeper, a blowout preventer, or BOP, is installed on top of the well. The BOP is a large, specialised safety device used to seal, control and monitor wells to prevent uncontrolled release of fluids. After the BOP is secure, a smaller drill bit is lowered into the hole to drill further, and more casing is cemented into the ground. This step is repeated until the well reaches a specific depth where the targeted reservoir is predicted or known to sit. This is called total depth and can be several thousand metres below the seabed. Drilling fluid, sometimes called mud, is continuously pumped into the hole while drilling. This helps keep the drill bit lubricated and cool to prevent overheating, prevents the uncontrolled flow of wellbore fluids, and transports drilled rock cuttings back on board. Rock cuttings are then separated from fluids using shakers. Fluid is returned to tanks on board the rig. Where required, cuttings undergo additional processing before being carefully discharged below sea level. The volume and properties of drilling fluid are continually monitored to ensure the well is drilled safely. Once total depth is reached, tests are run to understand the geological properties of the intersected rocks. Information on any hydrocarbons found is collected through rock and fluid sampling. The information gathered can be used in a variety of ways, such as informing future exploration activities, development planning, or optimizing production. Once wells reach the end of their life, they are made safe by sealing them with cement. This is called well abandonment. Before leaving the location, an ROV surveys the seabed again to assess and record the condition of the area. Woodside takes pride in the health, safety, and environmental performance of our drilling activities. We are committed to world-class environmental management in our exploration activities and in the design, construction, and operation of our facilities to help provide for the world's future energy needs.
So, have you understood, guys, how this exploration takes place? So, it is the pure engineering. We need to first do the survey, we need to figure it out the location, then we need to make sure that no maritime should get harmed because of that, and then we do the drilling. Now, have you, if you have heard everything correctly and clearly, so once the drilling operation is started, we need to put the cement so that the pressure which is getting out from the walls or the seabed, at the same time the pressure of that water, that we need to mitigate. Then and only then I can extract the oil from it. Right. So this is the basic which we learn under the fluid mechanics. The more depth we go, the maximum will be the pressure because of the water level above it, or we can say the water column above it, right? So we need to design a system in a such way that it can withstand such kind of high pressure, and then we can do the exploration and we can figure it out the exact location and remove the or get the crude oil out of it, right? Now, once this crude oil is getting out of the seabed, along with it will be having some stone, mud, and it is the mixture of everything. Then at that early stage, we need to do the refining, we need to do the segregation of the elements differently, and then need to store under the storage tank. So if we are talking about the system which is the offshore, then that system should have the storage tank where we can store this combination, and from that end we need to transport this mixture of your oil, water, and the sediments and everything to the shore, to the onshore, and there we'll do the further processing. Now think of it, I need to install a pipe which is carrying such kind of combination of elements, and I need to transport it from the mid of the sea to the land. So there the actual engineering will start, and we should have such kind of mindset or I'll say the our mind should be trained in a such way which will think of every possibilities that will occur during the transportation. So such kind of knowledge we don't get it from the college, because during the college the main aim is to make a base or make your foundation strong with a principle. So if you have learned correctly the fluid mechanics, if you have learned correctly the I'll say the strength of material or the thermodynamics or the maths, then the utilization of such knowledge here during the training or during the piping design engineering course, which will give you the further boost in your career. Okay. So now we'll move further. So we discuss about how the oil is getting out of it and how what are the different stream of industries we have. So as I said earlier, on every stage and in every stream there is a career opportunities for each and every engineer. But the thing is, we are not well aware where to look and what to look. So, as a Suvidya Institute of Technology, we are here to guide you because we are always like we are here in this industry from last 24 years, and we are very well aware about how this oil and gas industry work, how this EPC sector work, and how the engineering and the institutes are working. So this is our mission to to bridge the gap between this industry requirement and the institute which knowledge they provide. So we are always there to bridge this gap between the industry and the institute. So moving further, there are different career opportunities for each and every engineer. Now let's say if I talk about the process engineering. So when we say process, we are well aware about that the mechanical, electrical, civil, and then EXTC, electrical, IT, computer. But there is something called the process engineering. Now, in this process engineering, what do we exactly do? So the major aim of this process engineer is to convert under the chemical industry. They work for the petrochemical, they work for the pharmaceutical, they work for the refinery plant. So their main aim is to design this thing. How, what kind of raw material I'm getting? Okay, then what will be the temperature? How I'm going to separate it? What are the different equipments will be needed? So this everything knowledge that process engineer should have. Okay, so this process engineering, I'll say it is a starting point of your EPC project. Now the question may come, what is this EPC project? So have you guys heard this before? What is EPC? Some of you who work for the HPCL, IOCL, or Aramco plant, they are very well about this EPC. But rest of you guys, have you heard this word before? What is this EPC sector? Okay, Tejas, it's saying it is the engineering, procurement, and the construction. Okay, nice. So we are aware about its full form that this EPC is nothing but your engineering, procurement, and the construction sector. So when I say engineering, so it itself is a vast field where the lot of work before actual the startup of the project we need to do. Then comes the procurement. So whatever we decided in your feed and detail engineering, so all those components I need to procure under the procurement stages. And then comes the construction. So the equipment which I have on the site, the design data which I done during the engineering, and I need to make the real model now. I need to make the system work now. That comes under the construction. That is the broadly we can say about it. So as a process engineer, what are the different skill set I should have? So I must know about the mass and energy balance. So I must know the energy principles. I must know how the mass is transferred. I must know all the processes, this adiabatic processes, isochoric, isobaric, those processes which we learned during our engineering. Those things should be clear with you in your mind. It must transfer subject, but then I guess the engineering universities change it. Then what kind of work I need to do as a process engineer? So during this upstream, midstream, downstream, and when I get the product and I'm doing the refining process, I'm working on that raw material which I'm having. So what kind of things I need to do? I need to prepare the PFDs, I need to prepare the PNIDs. So have you guys heard before this PFD and PNIDs? Okay, so this PFDs is nothing but your process flow diagrams, how the process is going to take place, from where it is going to feed it into the your equipments, right? So those comes under the PFDs, and PNIDs is nothing but your piping and instrumentation diagrams. So how the piping is routed, what is their diameters, what is their size, what are the critical lines where the high pressure, high temperature we need to deal with, those comes under the critical lines. Then those are the critical lines, for that we need to do the stress analysis. So this another stream comes, the stress analysis. So like this I should have the vast knowledge of the industry. And like someone my senior once said to me that better than use 60% of the time your common sense, and the remaining 40% is your engineering. But the young generation which we have, lack of some common sense I can say. So the problem may arise, but that is the jokes apart. But let's move further. So during this activity we generate the PFDs, PNIDs, and the equipment we need to size, like this much of volume of raw material is coming, then how to store it, how to process it. So such kind of activities as a process engineer we need to do. The job opportunity if I want to talk about, then we have the process design engineer, then process engineer, production engineer, plant operation engineer, commissioning engineering, your EPC consultant. So these are the job opportunities available for the process engineering. Okay, so the chemical engineering background should be there, as well as you must have or you must possess the knowledge of piping engineering. So combinedly, you can work as a process design engineer. So this is for the process engineering. Now we'll come to the piping engineering. So piping engineer is not as such a branch available in the engineering or the diploma or the polytechnic, but this you can learn once you are completed with your mechanical engineering or your production engineering or your chemical engineering. So once your base is clear with mechanical, chemical, and production, then you can start learning or start upskilling this piping engineering training. Now the question may arise that where we can learn such things, because during the engineering or during the college life we don't or we are not well aware about such scenarios or such things. So where we can learn this thing? So the answer to this question, it's simply what we need to do. We need to open the Google and write it down, piping engineering training program in Mumbai. Okay, what this is the basic exercise what we need to do. We need to open the Google and write it down, piping engineering training program in Mumbai. And you will be surprised that the first name which will came is the Suvidya Institute of Technology. So what we basically do under this piping? So we designed the network of pipeline connecting the all plant equipment. Like the process engineer, it decided these are the equipments that we need to put. Now, as a piping engineer, it's my job to connect these two equipments. Now, to connect it, it's not an easy task. Like you need to put the pipe from this end to this end in a straight way. No, it's not possible, because there are different kinds of utilities are there in the plant. So we need to look for each and every utility. We need to design this thing. We need to think over the elevation. We need to think over the temperature. We need to think over the pressure it is handling, the corrosiveness of it, the how hazardous this thing is. So we need to consider this criterias, and then we start designing the pipes. So piping engineering is not as like we just design the pipe itself. No, more than that what we do. So the as you can see, the skills required, what I must know or what are the knowledge I must gain. So it is the engineering drawing. We are well aware about the first angle method, third angle method, that is these things are clear. But when it comes to the piping isometrics, so it is the different scenario that we haven't heard about it before. So we need to design according to the ASME B31.3. Now there are 31.1, 31.2, 31.3. Such kind of codes and standards are there. But As a piping engineer, we must know which standard I need to use where and which code will be applicable where. So this knowledge we can gain under the piping engineering. Then we need to do the isometrics, we need to do the 3D modeling, we need to work for the AutoCAD. Then in that we have Plant 3D, E3D, PDMS, Smart Plant 3D. So such kind of softwares are there. So although by the software our work gets smarter, our work get reduced, but unless and until your principles are not clear, then there is a no use of this software. Okay, so we need to think in that way. Okay, then what are the activities this piping engineer do? So we do the material takeoff, we prepare the MTOs, we do the pipe support design, then we do the plot plan development. So such kind of activities as a piping engineer we need to do. And now the last question is, what are the job opportunities for this piping engineer? So once the completion of this piping engineering training, there are huge demand of these engineers. Like they work for the piping design engineers, they work for the piping layout, they work for the stress analysis, they work for the materials. Okay, so under the piping there are three different fields. The one is the layout, the second is the material, and the third is the stress. So once the engineering is done, it's your choice where you need to work. Either you can be specialized into the layouts, or you can be specialized into the materials, or you can be specialized into the stress analysis. So for the stress analysis, Caesar 2 software is there. For your 3D drafting or the drawing and the designing, we have the Smart Plant 3D, then E3D is there, PDMS is there. So such kind of softwares are there to understand more about the designing and drafting. Okay. Now we talk about the process, we talk about the piping. Then there is something called mechanical design of process equipment. Now we know the process engineer work, we know the piping engineer's work, but this process equipment designer will design the equipments under which the process actually going to take place. So what we design? So we design the pressure vessels, we design the heat exchangers, we design the storage tank, we design the reactors, columns, and other static equipment. So apart from your turbine and the compressor, the rest of the things comes under this static equipment. Those equipments we don't, which are not revolving, which are not moving, comes under your static equipment, and other comes under the rotating equipment. So rotating equipment engineer is the another stream that is also available into the industry, and this static equipment designer is another stream. So you can see this oil and gas industry provide you lot of career option, lot of job opportunities on different stages. So this knowledge we are lacking in the institute. So that is why Suvidya Institute of Technology is there, which creates such a platform which gives you such immense knowledge that by which you can do your career best in different sectors. So the skills which required for this mechanical design of process equipment, you must be aware about the strength of material. That is the basic, or I'll say that is the principle of your every design. You must know the strength of material, you must know the properties of material. At this temperature what will happen, how the structure will be change of material. So should I use such kind of material in this temperature range or not? So this basic knowledge I should have. Then the other skills which are needed as the machine design, then your pressure vessel design, then tema standards, then API standards. So I must know how to utilize these standards while designing my component. So this knowledge you will gain under the mechanical design of process equipment. Okay, then the question comes, what kind of activity as an engineer I need to do? So In these activities, you need to design the nozzles, because if you are dealing with the pressure vessel, then the thickness calculation will be there. How much thickness should be there? Because when I am doing the thickness calculation, I also I must have the knowledge about the corrosion, how this corrosion will affect the life of this pressure vessel. So that's why your strength of material and the material basic knowledge you should have. Then the fabrication support. Now I design the pressure vessel and such kind of pressure is there. But when I'm putting it, it is not always necessary that it will be kept on the ground. It will be mid somewhere, or it will be underground, or it will be over the ground. So where I need to put the supports, that is also important. Because during our engineering, we I guess we learn the center of gravity concept, so CG. So when I'm designing the pressure vessel, this CG concept is also important, because based on that I need to look for the support where I can put the supports with it, right? So as I said earlier, your basic common knowledge or common sense should be there, and some part of engineering should be there. Are you with me, guys? Like, we are doing it perfectly well. Have you understood about this mechanical design of process equipment? Okay, okay. So, right. So we'll move further. So once, so if you have any doubt, you can put it under a chat box so we can discuss further about it. So the job opportunities for this is the static equipment engineers, the mechanical design engineers. I don't understand your question. Static equipment engineer, mechanical design engineers, then pressure vessel design engineers. So such kind of job opportunities are available under the title of your mechanical designer process equipment engineer. So static equipment engineers can work for such kind of job opportunities. So this comes under the knowledge. It is not possible to directly work on this title unless and until you don't have that base, you don't have that skill set. So once you gain this skill set, then you can work there as a static equipment engineer. Then you can work as the mechanical design engineer. So as a pure mechanical engineering, fresh graduates cannot directly jump into the such kind of job titles unless and until he is gaining some skills into the field. Because what happened, we are the raw we are the raw material, as we can say. The fresh graduates are the raw material, and industry now, as the 4.0 is going on, everything is automated and the time saving is more important. So in such scenarios, industry are not ready to put so much time on the fresh graduate, that they will teach them, they will spoon feed them. So it is like, it is the investment of time, and it is investment of huge money onto the fresh graduates. So that's why, if it is possible and if you have the chance to upskill yourself, you can skill up your knowledge, you can skill up your experience, then it is the ready to serve dish for the industry. Then you can think on that point, like, industry will go for the fresh graduate on which he need to put so much of time, so much of money, or he will directly go for the ready to eat dish, right? So we need to think of the psychology of the industry, what they needed, and how I can reach till that point. So the next is for the rotating equipment engineer. As we talked about earlier, the static equipments. So now this is the rotating equipment. So the rotating equipments, under which we have the pump, the compressor, the turbines, the blowers, the fans, everything. So this things comes under the rotating equipment. Now, as a rotating equipment engineer, I must be aware about the pumps and compressor. Now this much of pressure is needed, or this much of head is needed. So what kind of pump I can do? Is it possible to do it with a single stage, or should I go with a multi-staging, or the impeller should be open type of impeller, or it should be a closed type of impeller, the material of impeller, will it affect my utility? So these things, this idea we should have. So as a fresh graduate, it is difficult to get it. Okay. So what kind of activity as a rotating engineer we need to do? So we need to do for the pump selection, we go for the compressor sizing. See, the RPM and the power of the compressor or the pump will be same, but still the impeller size may vary. And according to that, your pump curve are changing. So for different application, different kind of pump curves will be selected. So it is a very crucial thing. It is not that easy to go in the market and buy any kind of pump. So a in-depth engineering knowledge is needed. So for this rotating equipment engineer, what kind of job opportunities are there? So they will work as a rotating equipment engineer, they will work as the reliability engineer, the maintenance engineer, the mechanical project engineer. So such kind of job opportunities are available into the industry of this oil and gas sector. So I hope everything is clear with you. Okay, do we have any civil engineer? Any civil engineer is there? We have the mechanical, we have electrical, and I guess chemical is also there. Okay. So this civil engineer, okay, we don't have civil engineer here, but there is always something for each engineer. So as under the civil engineering, okay, we have the majority of mechanical engineers, right? So for the civil engineering guys, so what they exactly do, their scope is not just limited to making the bridges and the roads. No, their scope under this oil and gas sector is to prepare the foundation for each and every equipment. Now you can see when I put the equipment on the foundation, the weight is acting. At the same time, when the raw material is poured into it, the weight will change. Let's say the agitator is fixed into it and the rotation is going on. At that time, the forces will change. So need to think in that broad spectrum, that what kind of forces will be act, where it will act, so where I need to put the support, and how much strong that foundation should be. So such kind of skills as a civil engineer or the structural engineer, it is needed. So design of foundation, buildings, pipe rack. Now this pipe rack is nothing but a rack on which different diameters of pipe of different lengths going on. As a plant in as a process industry or the chemical industry, you might have seen in the pictures or movies or on the Google, you might have seen different photos. So where the different diameters of size of pipes are going from one end to another end, so each and every pipe is supported, and the support calculation is also important, the strong foundation is also important. Okay. So as a civil engineer or the structural engineer, we need to provide the structural support for the entire plant. Wherever we have the equipment, wherever the racks are going on, there we need to provide the support and a strong foundation, because it is not a one day task or the few years task. This equipments and this thing will be there for the longer period of time, 20 to 25 years. So I need to think in that way, that for next 25 years how this thing should be supported. So the activities we need to perform, or as a civil engineer and the structural engineer is need to perform: the foundation design, the pipe rack design, the steel structural design, such kind of operations this structural engineer need to perform. Okay. So the job opportunities which are available in the market are the as a structural design engineer, your civil design engineer, your foundation engineer. So such kind of job opportunities are there into the industry. Okay. Then for the electrical system design, for the electrical system design, what we need to do, like we have so much of equipments, so each and every equipment should get a proper power. So this power generation and the power distribution is very much important task. If we are not getting the sufficient power, if the pump ampere is not that perfect, that proper, then the working of that pump will get affected, right? So that's why the proper power distribution, your generation of power and utilization, everything is very much important. And the skills required, so I must know the power system calculation, I must know the electrical machines and the protection system. So where I need to protect the hazardous area, in hazardous area how I need to protect my pump. So for that there is a different study that will comes when you work into the industry, or when you learn something new, and when you go out of your comfort zone, then it will be easy to learn these things. So the activities that we need to perform is the load calculation, your single line diagram preparation. This SLD preparation is nothing but single line diagram preparation, your cable routing, your earthing design, your lighting calculation. So such kind of activities we need to do under the electrical system designer. And the job opportunities, there are the job opportunities. As you can see, whenever we use the equipment, we need to provide the power. So whenever there is a requirement of power, this electrical system designer or the electrical engineer will be there. Okay. So the power system engineer, your electrical design engineer, your substation engineer. So such kind of jobs are available in the market for the electrical engineer. Then it comes to the process instrumentation and control. So we talk about the process engineering, we talk about the mechanical engineering, civil engineer, electrical engineer. Now there is something called instrumentation. We do have the instrumentation engineering during our engineering time. You might have heard some colleges used to offer this instrumentation, but now most of colleges are just shifting from their instrumentation to the I guess IT is there and the computer science is there. So such kind of what's it, the branches are there, and the instrumentation is, I guess, under Mumbai University, if we talk about, there are few colleges which offer such kind of courses. But there is a huge demand for this instrumentation control engineer into the industry. So what they exactly do, their major role is to automate the system and give a proper sequencing operation. When we say PLC and DCS system, PLC SCADA system, so they need to put this logic. But to put this logic, they should be aware about the process we are doing. So the as an instrumentation engineer, we must know the basic of process, like what kind of process is happening here, and then how I am going to control it with the help of some sensors and the instrument. So this is the major role of your process instrumentation and control engineer. So the activities which they perform are the instrument selection. So what kind of instrument should I put to sense it, to control it, and to operate it? Then we need to generate the lookup diagram. We need to do the your control philosophy, like how I am going to logically control the process. So such kind of things comes under the activities that the instrumentation and control engineer need to do. Now the question is, like, what are the job opportunities available? So yes, there are different job opportunities. You can work as a PLC engineer, you can work as a control system engineer, you can work as the instrumentation engineer. So such kind of activities and such kind of jobs are there in the market, which a process instrumentation and control engineer can do. Now, apart from your pure mechanical and pure electrical, there is this new branch which we called as a MEP. So, have you guys heard before about this MEP engineering? Have you guys heard before MEP? Okay, what is the beam engineer and what its role in a EPC project? Is it related to the civil engineering? So beam engineer is nothing but it is like a BMS system, and where we are gathering the information, where we have the sensors, we are putting everything under the one roof, through which we can control the process, through which we can monitor the system. So such kind of operations are there in the EPC industry, but where we have the engineering terms and the actual construction work is going on, after that such systems comes under the picture. Okay, mechanical engineer can do the PLC course. Uh, I'll rather not suggest to do the PLC. They can do the PLC course, but if I look on the border picture, so where instead of doing a PLC course, I'll rather give you what a mechanical engineer can do. He can design the system. So as a mechanical, we have that advantage that we know about the fluid mechanics, we know about the strength of material, we know about the thermodynamics. So by using this knowledge, we can design the system. See, PLC, programmable logic controller, control the system. But as a mechanical engineer, we should design the system. So we must go for the design engineering rather than your instrumentation. Because if we are talking about the job perspective, so for the PLC, the instrumentation engineer will be much preferred over the mechanical engineer. Okay. So this MEP, okay, here the MEP and the HVAC. So the MEP is nothing but your mechanical, electrical, and plumbing. So whenever there is any commercial building setup, any let's say office building setup, or the hospital is there, or the restaurants are there, or the airport is there. So whenever we have such a huge construction where the large number of people will be there, so then the MEP engineer comes into the picture, because this MEP engineer can have the knowledge of your HVAC system. So under the mechanical, the HVAC systems come. Then under the electrical system, we need to look for the cable sizing, your cable tray, your transformers, your generators. So this thing comes under the electrical. And when I say the pump, your plumbing, so under the plumbing, your overhead tank size calculation, your underground tank size calculation, your pipe calculation, your pump selection. So to make this structure tenable और tenable environment create करने के लिए जो basic requirement है वो आता है MEP engineering से. Okay. So as a MEP engineer, you are having the knowledge of mechanical like a HVAC, you are having the knowledge of electrical, you must have the knowledge of plumbing, also you must have the knowledge of fire and safety. So these things comes under the MEP. And let's say like you are the owner, and you are going to design this system. So instead of putting different specialized personality for different stream, what I'll do, I'll select a one guy who knows everything about each discipline. So that is the profit to the owner, right? So that's why the owner always prefer a MEP engineer as their general contractor. So this MEP engineer can complete the work with the help of your HVAC engineer, electrical engineer, and the plumbing guy. So the combined knowledge we can get under the MEP. So that's why it is also in very much boom. We have the industry needed this MEP engineers very well. Then for the production engineers. So initially, the production engineers, which are nothing but working under the manufacturings and the operations. So to make every operation complete and to make the manufacturing process more smooth, these production engineers are needed. So what they do? So their main, what I can say, the aim is to optimize the system, to make it so simple and to make it so time saving that your operation should get completed within the minimum time. Because We learn this about the lead time and the waiting time. So whenever we have this lead time and waiting time, what happen, because of that the cost is increasing, and when the cost is increasing, we need to optimize my system so that the amount which I am putting into it and the time which I am putting into it should get minimized. So such kind of engineers are well needed under the EPC sectors. So what happened here? The skills they require are the manufacturing processes. They must know how the things can be manufactured. Let's say we need to do the welding. So what kind of welding? Welding is much needed here. Should I go with the MIG welding? Should I go with the TIG welding? Or should I go with the arc welding? So this knowledge should they have. They must know about the lean manufacturing. They must know about the Six Sigma. Like you might have heard about the Toyota philosophy, where he mentioned about the different losses, seven losses. So the waiting time is the loss, right? Then we have the manufacturing system such as a first come first go basis. So where the raw material comes first, we need to put it under the process. We need to do the clamping, drilling, what are the operations we have, declamping, put it into the next task. So such things comes under the production engineering and manufacturing and operations. So what kind of activities as a production engineer we need to do? So we need to do the production planning. So let's say after the 3 months, such kind of product demands will be huge. So I should priorly manufacture it. Then when I'm manufacturing, I must consider the cost I need to put when I'm going to stock that product. So the stocking cost is also there. So each and every calculation, each and every financial calculation should be in your mind when we are designing such system. Our main aim is to cost reduction. So by saving the cost, how I can improve the production. So such kind of activities comes under the production engineering, manufacturing and operations. So is there any job role available or the job opportunities are there in the industry? Yes, we do have like a production engineer, manufacturing engineer, operation engineer. So such kind of operations we can do. So this is about the production engineering. Now, apart from your core engineering and core polytechnic knowledge, there are other opportunities available into the industry. Is okay. Is automobile the worst field in mechanical? It is no, no. See, we can't say like this that this field is good and this field is bad or this field is worst. Why this happen? Because as an engineer we are not much aware about the opportunities and the possibilities that we can get. That's why we are cursing such branches. As an automobile engineer, if you are good into the designing, if you are well aware about the software tools available in the market and you specialize, you gain that specialization in that particular softwares, then it is the very good field for the automobile engineer. See, as an automobile engineer, you can't work under the piping. So you have the skill set, but you should know where to utilize this skill set. And if you are lagging between this information, then our career is not growing, right? So as an engineer, you must know what are my strengths, what are my weaknesses, and how I can put my strength into my career so that I can escalate. Okay, so that is the issue. That's why many engineers are not getting this core engineering job. Either they move to the IT and computer because many jobs available in only contract with a low salary. See, during the initial stages of your career, this may happen, but that doesn't mean that you will not get succeed. So figure it out. What is the gap there? What kind of skills are needed to the industry? And do I have those skills? If you don't have, then work on your skill set and then you can reapply. So you will definitely get succeed. See, ups and downs are there in the career, but we should always stay strong. Then we can proceed further. Okay. So should we move further? Okay. So The next is the common opportunities for all the discipline. Now you done your engineering, you done your diploma, and now what further we need to do? So the common opportunities, yes, the common opportunities that we can do or we have are the, like, we need to convert the engineering concept into the detailed drawing. Now let's see here. As an engineer, in our mind, I know what I need to manufacture or I know how I need to do it. But just by keeping your thought in your mind, the things are not going to work. You need to put it on the paper, and the engineer's language is the drawing. So unless and until your imagination is not going on the paper and you are not exploring it or the explaining it to the someone, then it is not possible and it is not feasible to construct, right? So when I say the EPC industry, your engineering, procurement, and construction, during the engineering, I come with one thought that I need to design this process. Then that time I need to put it under the drawing. So either it may be a 2D or it may be a 3D. If you are doing the 3D modeling, then it will be a proper visualization. You can check it from any of the angle and you will get a clear picture what I am going to do, right? So this is what comes under the drafting and design. So here at the Suvidya Institute of Technology, we do have such training program where the non-technical background people like the HSC completed, 12th completed, or BSc, MSc completed, and those who want to comes under the engineering field, so they can opt for such training program where they get learn about the engineering. Because as an engineer, our way of thinking is something different, right? We can see every situation, every problem in a different perspective, in a different angle, and that is in our, what you can say, that is how the engineers work. They always go for the problem solving. So but if you are not an engineer and you don't have that much of technical background with you, but we are here to get that technical touch in you, so you can also able to see the any problem with a different perspective, and you can solve it very well. So under the drafting and designing, what the activities as a drafting engineer or the design engineer they must do, so they need to prepare the engineering drawing, they need to prepare the isometrics, the structural drawing, electrical drawings. Now, when I say drawing, it is nothing but we are routing it. Let's say from one end to another end, I need to put a pipe or I need to put a cable. Then how it should go? What are the different restrictions will be there? Let's say beam restriction is there, and the different columns are there. Let's say the fall ceiling height is not that appropriate. Then in certain situation, how you are going to do? So that knowledge you can gain under the designing and drafting field. Okay. So once you have that base clear, then it will be easy for you to design further and solve the problem very fast. Because in this industry, your time is the money. How much time you are taking to solve the problem is the loss to the company. So that's why we our brain should work very fast and very smooth, that whenever you see such kind of issues are there, you should start getting the solutions. I can do it this way, I can do it that way. So that knowledge you will get unless and until you are not upskilling your knowledge, right? So this is how this industry work. Now we talk about the engineer and their role, their job, what are the different things and the skills they must have. But here, this whole oil and gas sector is having different stages. Like initially we talk about upstream, midstream, downstream. So same way, the one chemical process plant have the different disciplines and the different stages. like like I mentioned here, the technology development, the feasibility study, feed, basic engineering, detail engineering, construction, and everything. Let's say for example, I need to manufacture a cream. Okay, I need to manufacture a cream, that cetaphil and everything, those which are there in the market. So let's say I need to manufacture a cream, then I must need a raw material, the different combination, the different chemicals will be put under one, what we can say, the vessel where I'm mixing it, and the desired output I'll get it. But this is just my thought. This is the idea which I need to put it on a paper, and then I need to look for the equipment, and then I need to look for the process, and then I'll get the output, right? So technology development are those companies which are having the technology with them. So you need to give them the idea, like, this is what I need to do. I am going to manufacture a cream, and this will be the content. So the technology development, those companies will give you their technology. Okay, this is the combination how this thing are going to work. This comes under the technology development. Then there is come feasibility study. Okay, you have the thought, and this is the technology, but whether it is possible to do, whether the place where I am going to put this plant have that capability to sustain, or whether I am having that funding, or how much amount is needed to complete this project. So this will comes under the feasibility study. Okay, so we'll look each and every topic in detail here. So as I said, technology development, the concept development as per the requirement of client or the customer. So I am the client, and I need to manufacture the thing. So the technology development will give me the ideas ki how we are going to do collaboratively. So what are the different departments which will come under this technology development? So you'll be having process engineer, your R&D, your mechanical engineer, and design of process equipment. Because the process engineer will decide what kind of equipments are needed, where I need to put it, how I need to connect it. So this comes under your technology development. Then next is the feasibility study. So as I said earlier, I need to check the viability of the project, how much costing it will take to generate this product. So this things is the feasibility. I need to check the feasibility of the concept. I have my concept in a mind, but whether I am able to put it on the paper, whether I am able to put it on the actual world, so this comes under the feasibility. And during for this feasibility, we'll be having mechanical engineers, we'll be having process engineers, we will be having structural engineer, electrical engineers. So all the different engineering fields will be combinedly there for this process plant development. Okay. Then once the feasibility is done, what I need to do? I need to do the basic engineering. Now, what is this basic engineering? I need to sketch it out that this equipment will be there. This is the process. This is how it is going to flow. I'm going to mix it here. So such kind of rough structure I need to put, and that comes under the basic engineering. So once this basic engineering is done, now you can see the previous photo where we are just putting a schematic, like this is the equipment, this is the line, this is how it is going to do. And in the detail engineering, okay, sorry, in the detail engineering, I need to put everything in a such a way that based on this detail engineering, the actual equipment, the actual length of pipe, the quantity of pipe, the quantity of equipment, everything is going to be purchased. So that's why detail engineering is very much important, and it is very much crucial thing, because during the detail engineering, the piping engineering will be there, the piping department will be there, your process department will be there, the structural department, electrical, HVAC, everything, everyone should be on the common ground. Then and only then the equipments will be finalized. Okay, so this is how the detail engineering we do. Then comes the construction. Now I done the detail engineering. Now I need to fabricate the equipment, because in the detail engineering it is mentioned from 2 meter length of pipe, this equipment should be there. This is the height of that equipment, and this is how we need to connect it with such kind of processes. So everything which is mentioned under the detail engineering, I need to complete it under the construction. So your foundation work, your civil erection, your equipment installation, everything will comes under the construction stages. Okay. So I hope you are getting it. Just a minute, guys. So all of you reach here till the inspection and testing, or anyone left behind? I hope you are getting it perfectly, right? Okay. So the next part, yes, the next part is the inspection and testing. So we did the construction, and now what is this thing? We need to inspect it, because whatever we constructed, whether it is having that much of strength, whether it will withstand for next 25 years, so that I need to check. So that can be done under the NDT, that is non-destructive testing. We do with the help of, there are different processes under the NDT. You can do LPT, MPT, DPT, so such kind of, or UT, so such kind of processes are there. Based on that, we can check whether the construction which I did is perfectly strong or not. Okay, then there are different testing, like a hydro testing is there, pneumatic testing is there, vacuum testing is there. So such kind of testings are done under the inspection and testing. So as you can see, on every stage I need a engineer to do this job. So that's why the demand of engineer is so much huge under this oil and gas sector. So then it comes the commissioning. Now I constructed everything as per the detail engineering, but then I need to check whether the desired output which I am getting it or not. So this commissioning is nothing but your actual running of the plant. I'll run it, I'll do the test run with a different loading, and I'll check the output. So whatever mentioned under the detail engineering, I'm getting it at the output, I'm getting it at the outlet or not. So that is the exact work of the commissioning engineer. And then the last stage, which is the operating maintenance and training. Now the your commissioning is done, then I need to hand over this project, right? So when I'm doing the handover, I need to train the next set of people who are going to handle this project, right? So that comes under your training. Then I need to do the maintenance and operations, so such everything will be there. Then you can see here also I need the piping engineers, your equipment engineers, your electrical engineer, then your instrumentation and control engineer. So on each stage I need every engineer should be present there. So let's see the overview of your the process plant, how it look like. Okay, so as you have seen the process plant, so initially we need to do it on the paper, the 2D drawing. and then the actual work begin and we convert it into the 3D model. So the 3D model gives you the better understanding, the better idea, how much spacing we need to keep between the two equipments, the two structures. So that's why we do the 3D modeling. Then, as we mentioned earlier, the smart plant 3D and other softwares are there which under which we can work. Okay. So these are the companies, those are the process technology provider. Like I said earlier, if I need to manufacture a cream, I must get someone who will do it for me. So these are the process technology provider. The Vickers is there, then your Honeywell is there, then the Linde is there. So these are the companies which provide the process technologies. Then the detail engineering companies. So as an engineer, we must know what are the giants are there into the industry, and it should be my aim that once in a life I should work under this company. But to get it there selected is not an easy task. You must have those skill set, then and only then you will get a chance to work under these giants. So for the detail engineering, the Jacobs is there, Petrofac is there, your Floor is there, Mott McDonald is there, then Bechtel is there. So these are the companies which do the detail engineering. Then for the construction, Godrej is there, NPCC, L&T is there, and Siemens is there, Fabtech is there. Now we learn everything what is needed, what we can get, but the question is still there: how to get this? So we, as a Suvidya Institute of Technology, are there in this industry from last 24 years, and more than 23,000 of students we train under this roof of Suvidya. More than 650 batches are done and 30 plus nationalities are trained till now. We done the training for the Nigerians, we done the training for the candidates from Dubai, we done the training for the candidates from the South Sudan. So the different origins of people came here and train their skill set. What we provide, we are under the certification of ECITB, that is that the certification is provided by the United Kingdom, and the NSDC, that comes under the National Skill Development Corporation. Okay, so the idea about this Suvidya is in the mind of our founder, Honorable late Mr. Vasant Dinkar Mistry. He thought that the industry needed such kind of skill set, but our institutes are lagging in it. So why not to start a something which will help the industry to get a trained manpower? And that's why the Suvidya Institute of Technology is founded. So if you can see, the training done for the different nationalities is almost more than 39. The Vasant sir designed more than 100 greenfield projects and brownfield projects, conducted more than 250 seminars. So such kind of huge skill set he have, and that's why Suvidya is standing tall till this year, completing of 24th year. Still we are in the industry and providing the skill manpower to the industry as per the requirement. These are our trainers. We have the trainers of working experience more than 20 years in the similar field. They have their own consultancy. They do the designing of various greenfield and brownfield projects. So these are the real assets of our Suvidya Institute of Technology. We train, as I earlier said, we train many nationalities. So the peninsulas, US, Juba, South Sudan, Cameroon, the Australian, Sharjah, Dubai, Oman, Muscat. So for the different location, we do the training, as well as this foreign candidates come to the Suvidya Institute of Technology here in Santa Cruz, as well as we are in a Pune. So we run these courses or the training programs at the both locations. We also conduct the seminars at the different engineering colleges like Vidyavardhini Bhausad Vartak, that is Vasai, then Thakur Polytechnic, then Zondre College, Theme College. So for the different colleges, we are doing this training program. As you can see, okay, the question is the greenfield and the brownfield. So the greenfield project is something where we are starting from the scratch. Like the land is bare land is there, and on that we need to do the project. On that we need to do the construction, designing, and everything. And as when it comes to the brownfield project, so the retrofitting is there, the plant is there, but there are some modification. The expansion is going on. So such kind of projects comes under the brownfield projects. So here in our in-house training program, what do we provide? So for the mechanical and production engineers, we have training programs like a piping engineering, mechanical design of process equipment. For each and every engineering field, we have the different kinds of training program. All this information is also available on the website. So if you can just type this with the Institute of Technology on the Google, you will be directed to our website and you can figure it out the different training program, the different upskilling training program for your career, which will be further helpful for you to escalate. We have the placement for in-house students. So each and every training program start after your completion of degree. Then you will enroll here for the different training program. Your skills will be upskilled. You can gain the industry knowledge and the industry exposure. And once everything is done, you will be placed in this particular industry through the Suvidya Institute of Technology. So if you can go on the website and check for the placement record, we provide the 100% placement assistance to all the students of all training program. We are currently running almost 16 training programs for the different individuals. So you can directly visit our website and you can get this information there. So after this whole talk, I hope you learn about the industry, the oil and gas industry, how it work, what are the different sectors and what are the different career opportunities you have. So as a final thought I am giving you, you done your engineering, you are completed, you done your engineering, you completed your graduation, but now the question is still there, in which field I should go or what stream I should select. So, if you are interested to make your career boom, write down in a chat box as a career so we can assist you further to select the right career path which will help you to grow further. So, I'm expecting that those who are very much interested to grow further must write down the career in the chat box. Thank you. Thank you, guys. Yes. So I hope you learned something new today. It is not just about the job, but it is about the right career path that we must select so that we can grow big, right? We've done the engineering, we've done the diploma, and now it is the vast opportunities are there into the industry. And to get that perfect choice for you, we as a Suvidya Institute of Technology is there. You can connect with us. You can come to the Santa Cruz branch or the Pune branch. Will there surely will help you to select the proper career for you. Okay. Thank you so much, guys. Thank you.